All right, so we're doing it live at DevOps Live. So my name is Ben. This is my awkward family photo. I know many of you, but can I just have a quick show of hands? Who is currently like working with Docker? Like you're using it, there's containers going out, people are using them in production. So John, of course, you said you just started with something?
About 3 weeks ago, I started a new job and they're using it.
Anybody else? Yep, all right. No? Okay. How many of you use them in like a dev test environment? Okay, cool. All right, awesome. I just wanted to, so I work for a company called Particle 41. I started the company in, I guess, late 13, early 14. But also during the day, I'm CTO for a company called Legal Inc. Particle 41 has a myriad of clients doing all sorts of wonderful things. We do a lot of Chef, and we also started running across quite a few people whose development teams were already using Docker, and they wanted some help automating the workflow. So the purpose of my talk here is I wanted to talk about converting to containers. So one thing that we noticed for a startup that we're working with is that we started to kind of create a lot of different, I won't say microservices, but a lot of different apps to serve certain functions. And then we started finding that we needed a QA environment, a staging environment, a production environment, and then maybe we needed to demo something for a new client. And so we end up with needing some operation between all of these some different server roles and in different environments. And what we learned is that, I mean, what you guys could probably imagine is that in QA, the amount of server resource actually being used compared to what you have to fire up is pretty different. So we noticed a cost comparison between wanting to have all these different environments for testing, but having to have individual boxes for each. Now, of course, Amazon gives you smalls and mediums and some choice there, so you can make it pretty cost effective without using Docker. But we also were experiencing as consultants this issue of I'm in a Ruby app one day, I'm in a PHP app another day, I want to do some Node over here, and we were finding it difficult to kind of keep our single Mac maintained. And then we were also seeing that, oh, we have these different Vagrant machines, but now we're configuring these different Vagrant boxes. You get 4 Vagrant boxes running, and even a nice, well-built Mac is starting to shoot sparks, right? So we, as developers, wanted to start to use Docker. So we kind of see it two advantages. One, we get this a little bit easier. Has anybody ever, while they're doing development, have you ever used a tool called Foreman or Forgo? Anybody heard of that before? Where in the root of your project, you would have this little proc file. And as long as all those processes started up perfectly from your proc file, the proc file was basically a way to get to a certain set of commands that would be managed in different processes. And you would start those, and then as long as they all started perfectly, then you could end them perfectly, and you could kind of start and stop all your app processes. Well, I found that pretty problematic, but when I started using Docker, it actually felt very similar, right? Where I could start up my Docker containers, I could do my testing I wanted to do, and life was good, right? But it felt more stable. It felt a little more resilient for me. I could close my Mac, come home, open the clamshell, and be kind of back where I was when I left work. With that Foreman process, it was a little rougher. And if everything didn't start perfectly, then I ended up in a process ended up in a situation where I was killing certain individual things to get the whole thing. It's kind of an on or off process. So this, to us, felt like a much better way to manage having a variety of different platforms running without having to slice the resources into different virtual chunks. So now let's kind of talk about real briefly, what is a container? I'm a little bit off the rails. Obviously, we already covered that. What is a container? Does everybody kind of know what is a container, right? It's a virtual file system running in a process. You have a better definition?
Yeah, it's like a lightweight virtual machine. So rather than having a hypervisor that accounts for your operating system and processes within it, it really is a segment of the kernel, of the Linux kernel that you're already running on your host. And in a lot of cases, it's now popular to have a virtual machine of a Linux box and then have Docker running inside of it. So, so if you're on a Windows machine or a Mac, there's something called the Docker toolbox that then makes that a seamless experience where it goes and generates the virtual machine for Linux and then has some client tools that proxy commands to and from it.
Right. So we ended up in a situation with a client where they needed to do a deployment of their application in a different country. All right. So what was really cool about this is, or what I found interesting about this is that in the US, we think of cloud as basically Amazon, right? I get a virtual machine, I can order its exact specifications, and I can create a bunch of these virtual machines, and then I have all these other services. We kind of get caught into that definition of cloud. In other countries where Amazon wasn't as prevalent initially, their version of cloud is you order and we will give you Metal with VMware on it. That's really like the Canadian version of cloud. There's no Amazon in Canada. I don't think there will be anytime soon, but it's just a different definition. It's still not on premise. It still kind of meets those, they get away with it, but it's just different. You're sitting there with a lot of potential. I think in our case, it was 2 HP Pro Reliant boxes with like 196 gigs of RAM or something, right? These were 2 really beefy boxes with a NetApp assisted storage array. Sounds good, right?
But it's outside.
It was in a data center. They just didn't have to touch it, maintain it, or anything. So you get this kind of different definition of cloud. Well, the traditional way, let's say you have an app and you're putting on there and you don't really know the resources it takes up. So the traditional way was to start slicing it into virtual machine chunks with VMware, right? Everybody's probably seen that, done that, been around that, right? Well, each time you do that, you're really segmenting the resources. So you're taking that 196 gigs of RAM, maybe you slice it into 8 gig chunks because you don't really know what your application's going to do on that yet, and you kind of throw it all in there. Well, what Docker would do in that same situation is it would still create those logical segments, but each container would have access to the entire resources, right? So nearly the entire resources. So rather than segmenting all that resource and kind of creating these logical groups that are constricted on resource, you're actually saying, hey, for architecture's sake, I'm going to segment these into containers, but I'm not going to restrict the resource availability that they have. That's different, right? So that's where we come to why Docker and why everyone's kind of talking about it is my paradigm for being on a dev box, right? Wanting a little bit more utility to run all my processes, and then businesses' desire to be able to run with more resources, but still keep things architecturally separate. Okay. All right. So now I'll get into the one-on-one here. So John let me know too that Docker Toolbox is available on Mac. The reason why Docker Toolbox is kind of a cool thing to check out is that I actually ran into this error that if the Docker version on my host machine, my Mac, was different than the Docker version inside my VM, then I would have to synchronize those before I could get working again. So with the toolbox, you just install the toolbox, it keeps everything in sync, and you kind of omit this likelihood of version disparity between your client and your host. So very easy to set up with Homebrew. So a couple of commands that I started to learn about that you'll learn very quickly is Docker machine is the way you're interacting when you're in development. You'll have I use VirtualBox. You can use other tools as well. But inside of VirtualBox, I will have a Docker host, and Docker machine makes that very easy. Docker machine up, and it basically starts, it puts a virtual machine in there with basically Docker up and running, waiting for me to issue my container commands against it, right? Docker Compose is a YAML file that's used to describe a Docker, and I'll show you those here in a minute. Once you were to do Docker machine, do a little bit of inertia there, you basically could write a simple Docker Compose that pulled in this Docker run hello world. So if you had a valid Docker machine, you could say Docker run hello world and it sparks up. This is probably, to get to Docker hello world, you're probably less than an hour, just really for the purposes of having to kind of read and get your bearings around a certain set of commands, right? Make sure you have a VirtualBox installed and all of that. So very easy to get started. Some people call it essence versus efficiency, right? There's a pragmatic programmer, I think, talks about that or somewhere. I'm not sure. But there are steps, like if you're repeating yourself all the time, people would call that inefficient. So this is like the essence. This is the things that you're going to be doing. And I'll kind of cover these briefly. So Docker machine restart. Also, you have stop, you have start. I just didn't want to be repetitive. Once you start up I just called mine doc host. Once you start it up, you're gonna run this Docker machine env. Are there any people in here that use fish shell? Any ZSH guys? Okay, good. We're getting somewhere. Bash with auto completion and all those goodies. Okay, cool. I was really surprised that I'm a fish shell guy. I love the thing. You should check it out if you haven't. It does have a little bit of learning. Since I'm a developer, I like the way it does functional augmentation. Like you can add to the shell by writing fish functions, right? And out of the box, it's kind of got some modern auto-completion features that I really like. I was really shocked that Docker machine env actually knew I was running in fish shell and gave me output that matched the shell that I was already using, which hardly any other tools do. So I thought that was mature. And then you need to make sure that these Docker environment variables are at least in the session, if not global to your machine. And what they are is, I'll show you some output here in a second. What they are is they just say, what is the IP address of my Docker host, right? And just there's a few basic environment variables that need to be accurate in order for your other commands to work against the Docker machine. I ran into this where for some reason I needed to regenerate certs. So I pulled my history and I just wanted to show you guys kind of all the unique commands. In my example that I'm going to show you guys, I actually wanted to build all my Dockers from the Docker file. So I created a project that I'll show you guys that really everything comes from the Docker file. There's another variety where you could just pull images off the public Docker repository or your own Docker repository, and so you would pull and run those. I built my own, and this was just to give me some additional control. So as I wanted to make tweaks, I just go into those individual Docker files and I kind of own those. So, and I think it was some of the Chef influence. I didn't want any golden image. I didn't want any kind of starting. I wanted to go from essentially Ubuntu base or Debian base and add all my stuff to it, like in these Docker files. So I'll show that to you guys. And then Docker Compose pull would pull an image that's kind of the other flavor, and then run, of course. And then this -d is an important detail. When you do Docker Compose up, of course, it's going to fire up all your containers. If you don't put the -d there, then what you're going to end up with is you're watching the containers. And that's really cool if you wanted to see some like debug or something. But the -d will just start them and give you your prompt back. in command line. So I wanted to build everything with a set of roles. I wanted to I wanted to kind of, and again, maybe it's the chef influence or kind of using some configuration management tools, but I wanted to construct everything with a certain set of rules. So I created this little folder structure in here to be able to kind of play with this. And then in the root, I keep my Docker compose file that says, hey, go build all these things. So I have my MySQL box, Nginx, and then I did a PHP FBM, and then later I also added a Redis into this demo. So you'll see those things pretty easily here. And then I'm also going to show you a little bit of server spec. Chef, I've been using, has anybody used server spec? You guys heard of that term before? So inside of my demo, and I've also put this on my GitHub. My GitHub is benjohnson77. There's a Docker 101 thing there that you can check this out. But I was really fascinated to see at ChefConf they started calling server spec basically chef compliant. I thought that was really official. But essentially what server spec is it's a way of checking if certain assumptions about a container or a virtual machine are correct or not after you do some process. So have you guys ever run these commands, lsof-i:3000, right? Or psef grep 443 or 5432, right? You're like, hey, is that service actually running? Is that port actually enabled? You know, are my assumptions about a thing really accurate, right? So I wanted this kind of infrastructure TDD, and that's what server spec provides you. So I'd highly recommend kind of doing a deep dive and looking into that, because it will really save you time. You can actually know, okay, on this particular virtual machine, these things are actually running, and instead of having to go in and do 15, 20 minutes of, no worries. Instead of having to do 15, 20 minutes of this kind of bash magic here, you can just run a server spec against the machine and know, like, this thing is up and running the way I expect. You can check to see if a socket file is there and is a socket file. It has a lot of pretty cool tools. So I also put that into my project. All right. So all right. So my workflow is now that I've done all of that work, I'll show you kind of the code here like I just described. All right, so I have my roles, MySQL, Nginx, PHP, Redis. And just to show you some flavor, I did Redis with an image instead of a build, right? So I would just do Docker compose pull, and it would pull all of my stuff, and then I could run, it would run Redis, build, and then I'd do Docker up-d, right? So this is like pulling it all together. Now I wanted to kind of play with some things. This is just an example of how you might run like a little database, a little data, like if you wanted to run something to get your database up to kind of a start state, right? Kind of load some data into SQL. They have a little notion of that here with the add database and then run that. And then, has anybody come across this supervisored? Okay, so inside of a container, we might want to supervise to make sure a process is running and doesn't start. When we ran some Docker containers in production, we definitely found a difference of just starting the process in the container versus running supervisor on that process. It just gave us a little bit more resiliency, where supervisor is monitoring that process and gives you a little more control on that process starting up. I wish I could give you a more technical definition of that, but we definitely saw a difference running in production using supervisor without using it. So any questions on like the choice here to kind of put it in this kind of file structure? And I'm asking because this is just was just a brain fart of an idea here. There may be better ways, but I just wanted to have a place where I could control my, my Docker environment. Any questions on this? Thoughts? Yeah.
Is it me, or is a lot of the syntax you can't tell if it's Docker syntax or it's the way you line it out? Looks very similar to the way Vagrant works.
Yeah, I mean, I hear what you're saying, but most of what I'm doing in here is, like, let's look at this Docker file. But this is just bash. So I'm prefacing run with a set of bash. I mean, if I can run it in bash, I just come over here and put it in a run line. Those commands may have some, I always had, like, my Vagrant file kind of had some Ruby-ish syntax to it or something, but that's, if you know bash, if you can do it in bash, you can come transpose that to the Docker file really, really easily. Any other feedback?
Docker run by itself, or you have to really integrate with any other tools?
I didn't understand the question.
Docker run by itself, or you have to invoke it from external.
So Docker is running on the server. Like, so if you have a host, it's running Docker on there. It's kind of managing these. It's the kind of the single program on the host where the containers are sitting on top of it. And the Docker machine command will manage that for you seamlessly. You don't have to. I never had to SSH into the Docker host. I could do Vagrant SSH and get into that box, but I never really had to. Any other questions?
Hey, just a comment. One of the cool things about Dockerfile is that each of those run lines is creating a new layer of the container. So a container is made up of layers. You have your base operating system, but then each run gives you a new hash that represents that layer, and so that can be cached. That means if you make a change to the Docker file, adding a new run underneath or at the bottom, it's not going to have to execute all those previous runs. It'll go refer to the cache and then refer to the state of the container at that point that it's already got cached, which makes developing Docker containers or Docker images very quick. You don't have to run through everything over again.
Yeah, I can show an example of that. So if I want to rebuild, so if I go make a file change in my Docker file, just like John was mentioning, and I do a build, it's going to go from the point of that and then just kind of build after it. So that was just a rebuild, right? A very quick, maybe adds 10 seconds to that, right? I don't know if you've done some iteration on chef recipes, had to blow away the box, rebuild the box. That can take a lot longer. I mean, you can really spend some time doing that. Not that it's bad, but you could spend some serious time going from up. Now, if I completely did away with my images and I did a pull of a complete rebuild from kind of a fresh Docker host, there's going to be some pretty serious like pulling net traffic, that kind of thing. But that is not often repeated.
So if you start or rebuild or restart one of the layers, you don't have to do the others?
So the workflow is I build, like I made a change in Nginx, for example, let's say I did a build and then I come over here and do an up, and it's going to replace those containers that were running under the previous image with the new ones here. Right? One thing I want to point out, because this was really, and I should have had that on my commands list, there is Docker attach, okay, and there's Docker exec. I did not know what Docker attach was actually intended to do. And early days, they actually changed the definition of Docker attach in my understanding. So I started to follow a kind of I follow a thing on Git where people end up if they try to do Docker attach, and that still gets people coming to it going, why doesn't this work? So Docker exec is how you're going to jump into a container and practice specific things. Now, in order to do that, Docker PS, I need to know this container ID. And once I know that container ID, so this Docker PS is the is the Dockers that are actively running from that Docker compose up
Can you
command.
make the text a little bit bigger?
Yeah, absolutely. Right? So, so I need to know that ID, and then I can do a Docker exec, and you can see I had been doing this before. So if I wanted to go into my my Nginx container and play around, oops. Now I'm inside of that Nginx Docker container, and I can play around and I can try commands and I can see what's happening. This to me got arduous. So instead, what I did is I wrote my specs, and now I can just run this thing. And what I'm playing with right now is that I want to see if I've linked. So when you want one Docker container to be able to access the port of another, in the Docker compose file, you link them. You basically say, I want to make this port available to this guy. So let me demonstrate that, or kind of show that. So here's my Docker compose. And you can say, I want to link to, I want my Nginx to be linked to my PHP. So in server spec, I think this port 9000 should be available. And for some reason, server spec doesn't agree with me. I know it is, but I want server spec to validate that for me. That's a room for improvement in my mind. So this is describing all of that you see. So when I did up, this is exactly what's running. Now for putting my app into there, I just did this Docker machine naturally shared my user directory with the Docker host. So I just leveraged that. I didn't try to fight with that NFS share between your host. I just kind of leveraged that. I said, cool, my whole user directory. I happen to keep my projects in my user directory. So I just map with this volumes, I map my user directory where I have my apps to home deploy apps. And I create this deploy user on the container, and I put my apps in there. So now I have access to all of that. And then in my Nginx container, I'm kind of editing the vhost to leverage that paradigm, right? So now if I were to take that container and deploy it, I would have home deploy apps with my application running in there, right? And I could drill down one layer deeper. I just didn't do that.
Is that
right?
Is the port syntax a range or inbound, outbound?
It's inbound, outbound. So on the external, I kept them the same. I see a lot of people like mixing them where on the inside it's 80, but on the outside it's 5,000. And I just wanted to stay simple. So I just kept the inbound, outbound. Now that may cause a problem in like a swarm environment where there's some port mixing, matching stuff kind of going on. But for my simplified example, I just kept them the same. So any questions on kind of this 101 or the server spec?
You said you never SSH into your Docker. Did you mean to the host? Or
Yeah, to the host. You could, like I could do Vagrant SSH and actually go into the server that's running Docker.
Yeah.
But I just never did that. I do this Docker exec though all the time. So I'll do the Docker PS, figure out my container ID, and then I'll do that Docker exec IT with the container ID, and I'll get in there and kind of play about and figure out what I might want to add to my Docker file. Once I figure out what I need to add to my Docker file, then I put it in the Docker file, build up-d, and then I never have to do whatever that thing is that I needed to figure out ever again, right?
If you do a Docker machine SSH and your machine name, it'll SSH you in there too.
Oh, okay, perfect. Yeah, I remember seeing that.
That's for the host.
Yeah, awesome.
So if you were only going to run one container for each of the like Nginx and SQL and all that, would it be useless to use Docker and just do it natively on the host? I mean, is it only useful if you're planning on running like multiple Unix?
Okay.
Multiple?
That's a really good question. So in order to answer that question, I have to tell a slightly longer story. If yes, your intention was just to run a single role or install something and run it, maybe. But apps now, they take a lot of different components, right? So I was a DevOps manager. We had about 15 different roles. Each of those roles, some are data services, some are applications, but there's at least 15 different things going on. And we made chef recipes for those and then put those out into production on a bunch of different individualized machines, had a good VPC architecture and all this. But the developers on the team were still unhappy because what they really wanted was a converged environment with everything kind of where they could touch it and play with it on a single box. So divergence versus convergence, I feel like, is a problem that Docker gets really close to solving. Where in production, I want everything diverged. I want it to have its own resources. I don't want to limit anything. I want to give it its own space. But in development, I want convergence. I want everything close together so that I can play with it and work with it. So I would say even if today you only think you have this one thing to run, playing with Docker, I think, makes that path from convergence to divergence a lot easier. Whereas with Chef and stuff, the development part was still a challenge. Because what do I give the developers in order to run those 15 different server roles? I can give them 15 different Vagrant boxes. Well, they're going to not really enjoy that because now they have 15 different Vagrant boxes that may or may not be all running at the same time, taking up all of their beautiful Mac resources, right? So Docker seems like a really good, cool answer to where I can play with things as I choose on my local environment, but that also could be a versionable asset that I could send out into production. Right? The last thing I wanted to cover was just a couple of, and this might be an okay segue into to John's talk. I want to talk about a couple of misconceptions, just real quick. We'll just breeze through these. If you learn Docker, you don't have to learn any other system stuff. That's probably complete opposite. And this is not necessarily of my opinion, but I thought it was a really good article. You should only have one process per Docker container. While I somewhat agree, my example was PHP. I did that with the sole intention of running a Laravel app. So I want to add Composer and Artisan into that container, where this paradigm would probably disagree with me. They would have Artisan and Composer in separate containers. And I actually saw some really good examples where that's the paradigm they used. So that's kind of where it gets sticky. I feel like if I need the processes for that particular role, then they should be together in that container. And that may be the thing that flame wars were made of. I don't know.
Just a concern if you have like 3 processes you're sending in one container, could there not be one process maybe take down the container for some unknown reason? Something happened and then the other processes are not running because
it hasn't been my experience because supervisor actually manage all 3 processes, but it's just a matter of, I think if you keep them all separate, then you know exactly what's going on. But like in the example of the Laravel ecosystem, it's PHP, it's Artisan, it's Composer, you need Bower on there. I wanted all that stuff that really dealt with that role to be in that container. And I guess the reason, for lack of a better one, is I wanted to be able to Docker exec into that container and do all of that certain stuff. I didn't want to have to go into this container for that. But there is some really cool implementations where developers had each thing into different containers, and then they created some aliases in their bash configuration, and they basically made a whole little micro application to do all those things in there, and it basically became seamless for them. That was cool. It just was a little more than what I wanted to invest in it. But but I've seen some really cool things. Has anybody used like Heroku or some of these like cloud type services? It was basically turning those implementations where they kept everything really separate and then added a lot of aliases into their bash configuration really became like your local little Heroku, right? So I just think that the misconception is that it has to be that way. It has to be all separated out. And then should I use Docker right now? I really like this part of the article because it's talking about, you know, should you have, you know, think about some of these things before you go tell your boss you need Docker. Like if you haven't done this work first, why don't you hold that conversation off until you have a plan for some of these things? If you haven't used fail to ban, you should probably be looking at some of this stuff first before you go chase the white rabbit. Docker's a pretty deep hole. There's a lot of support tools in the ecosystem. It's relatively new. So go clean house before you get too in over your head on the Docker stuff. You know, more misconceptions. Any of these guys resonating with you? Has anybody told you any of these, or have you kind of been here?
I think it's interesting about security.
I don't know. I don't think it's. I mean, that's good for internet fodder, but I didn't necessarily see a plus or minus on that. So then this is another really good article, Docker patterns. Talk about a lot of different ways of organizing this. I kind of found this article after I'd already started like the individual role-based structure that I created. The one I like the best though was kind of something John and I talked about where they're talking about, I guess it's version you were saying, and like kind of what I found interesting was basically if I gave these Docker containers to 5 developers, and I really didn't have a good connection in that release process like I do with a single server, right? I could have some kind of like chef grabbing a certain Git SHA and putting that there. I wanted this connection between a Git SHA and the container. And I felt like I was losing that, or I felt like I would be maintaining that somehow separately out of this process. So there are some pretty good tools that'll kind of combine those elements and make it a little bit easier for you to oh, inside of this container is this set of source code, and now I'm deploying this container and kind of connecting that source code version with the container version. And I still don't have a very good answer for that, but there's definitely tools available to answer that. And one of these paradigms was that way as well. I want to give John plenty of time. Do you guys have any other questions for me?
Could you expand on that when you give what you claim as giving the output to the developer? Why would you be giving it if you're having a repository? Shouldn't he be able to spin it up on his own and then get to send on?
Right. So I think that is a good thing, right? Because then the containers I'm using in production are kind of accessible to the developers. But in my example, that wasn't possible because I had done chef configurations to create virtual machines. I couldn't really take those virtual machines and then also give them to developers. So I felt like I was very diverged in my chef work and in creating this infrastructure, and I didn't have a solution that was properly, I was diverged in those environments. I didn't have a solution that would converge those and make those all available to the developer in a lightweight way. So that's where I see Docker having a lot of advantages because you can serve both those, the converged notion and the diverged notion somewhat simultaneously with the same amount of configuration work. Any others?
Just one other question. How do you manage versions of Docker? You said you have to work.
Like anytime you build the image, you get a different image ID. So trying to pull from memory here.
Do you use any kind of code or image management logic, or just code?
Yeah, Docker comes with its own. And then if, I forgot to add those slides, but right now in AWS, there's this EMC thing, this like Docker container manager thing and you can create your own private Docker repository in about 15 seconds. So all you would then do is change your environment variable to point to that repository instead of the Docker repository, and you could upload your own images to there and have that all private. But there is a public Docker repository where you can push and pull, and all those images are kind of living there ready for people to use.
Is that like if I have image and then I add one more image that's like different?
Then those would be two separate images.
There's no versioning aspect.
There is. So it's just like I have source code, and then I change the source code. I get two different SHAs.
Like Ubuntu 14.04.
Right. Right. Perfect example. So this is like Ubuntu when it starts, and then as I'm applying things, I'm getting different images. So when I choose to deploy that, I have a state of that thing with those configurations.
The layers, you can specify what you want the previous layer, specific tag, or you can say, give me the latest version of the underlying tag. So like Ubuntu, you could say, give me the latest. Like most of those just say tag latest. So they're rebuilding the code.
Cool. Give John plenty of time. How do you want to?
So I'm going to come over there and I'll plug my computer.
Okay.
Unplug yours.
Should I just stop sharing, or?
No, I'll take care of it.
Okay. You're a pro. What do we do without you?
Okay. Don't forget to mute yours. Yeah. All right, let's share my screen. All right. Okay. Cool. So how's it look over there on the screen? I think it's fine, right?
Yeah, it's good.
Yeah, good. Awesome. All right, so what we've looked at so far was Docker from a single host perspective. And so what I'm going to be demoing now is called Docker Swarm. It's another tool that's included in the Docker toolbox. And so Swarm is really cool because it lets you cluster together Docker hosts and then interact with them as if it was a single Docker host. So it kind of abstracts some complexity away from you. And so I'll demo that here. Some of these steps are going to take some time, so I'll explain the commands that I'm doing while it's executing. We'll make that bigger. Okay. So I'm going to let that go for a little bit. So the first thing that I'm going to do is I'm going to execute Docker machine to create some virtual machines. I'm going to use VirtualBox as my driver in this case. The reason that I'm doing that is because I want to make this as fast as possible. I can choose different drivers that allow me to specify nodes on AWS or DigitalOcean or something else, but to limit my risk, I'm just going to make these images show up on my local machine. So when I choose -D, the driver, as VirtualBox, it's actually going to create some new VMs with Docker installed on them. And then I'm giving them a name of node and then a number. So at the end of that command, we should see three virtual machines available to us. So as we can see, it finished node 1 there at the top. It's just about to finish node 2, and then it will go to node 3. So while that's going, I'll tell a little story. So I use Docker Swarm to do some pretty interesting scenarios. So I've got a couple of machines hosted in different data centers, And so I use Docker Swarm to cluster them together and then talk to each other as if they were on the same network. So it's using some really cool software-defined networking, components that are in there, so that way I can act like it's all one single, Docker instance. So that's really cool, especially if you have like high availability requirements for your applications, and you need, perhaps some containers to be deployed in different parts of the country or the nation or something. So yeah, it's pretty cool like that. So it's almost done with node 3. So I'll look at what's coming up next. All right, so the next step that we're going to do is we're going to get a swarm token. So these Docker nodes have to know how to talk to each other, and there's a couple of different ways that you can get them to talk to each other. In this case, we're going to run a Docker application called Swarm, and it's going to go and get a token from Docker Hub, and so that token is going to be housed in a public signaling server. And so each of these containers will call out to the internet with that token and then find out what other nodes are listening for it. So I mean, this is a practice that's fairly common in distributed systems. If you need to do something a little bit more complex, there are tools available like Console or etcd that allow you to do some of this kind of stuff. So my node's finished. I'm going to run the next command so that way I can get my my token. Okay, I've got the token actually stored as an environment variable now, so we can see it there. All right, next I'm going to create a swarm manager. So while we let VirtualBox do that stuff, I'll go and explain the command a little bit. Similarly to the nodes, we use the VirtualBox driver. We pass in some additional flags that tell Docker machine that this indeed is a swarm, and so this node that we're now creating is going to be the swarm manager. So when I using Docker machine, I'm going to connect to the manager, and then that gives it that abstract, view where I can then interact with my cluster. So I'll show that in a minute as well. Next is the swarm strategy. So the default is spread. We'll talk about strategies more in a moment, but I just wanted to specify it there as well. Next is the swarm discovery flag, and in this case, it's saying when you pass in that flag, it's saying I expect to go to the Docker Hub and do that whole like signaling process that I just mentioned, where I'm passing the token with the ID, the token value that I got from the previous step, and then I'm giving the node a name, calling it manager in this case. And it's done running now. So after that, we're going to join all of those nodes to the swarm. So I'll execute this. This should go pretty fast. I'll explain this. So we had 3 nodes, so I'm going to iterate through them. And so here I'm setting an environment variable that says run the following command from a Docker host. And so I'm picking one of the nodes to execute from. So in the case where I in this loop is 1, it'll go and execute this sub command, Docker machine IP node, and then 1 would be replaced with the I. So that'll get me the IP address of this first node, and then I specify the port number. So then when it does this Docker run command, it's going to be executing from that Docker host. And I'm going to run a container called swarm, and I'm going to pass it in the join argument, and then pass in a flag that is going to state its IP address. And so that command is going to then call to the signaling server, and then it's going to join them together. So it'll do that 3 times. After that, all of the nodes will be talking to the manager, and everybody will know of each other. Next, I'm going to set the context to the manager. So I execute this command. And then now I can get some information about the swarm. So I can run docker info. Okay, and so I can see that that I've got 4 nodes. So node 1 through 3 and the manager, that it is now clustered together. So it's swarming now. If I want to do like a docker ps, I don't have anything running at the moment. If I do docker images, I also I only have the swarm image that's available at the moment. However, if I do docker machine ls, oh, that's cool. I can hide this thing. All right, good. So if I do docker machine ls, it's going to query all of those different Docker hosts. So so I'll start here. So from the manager, you can see that it is specifying that the manager is indeed a swarm master, a swarm manager, and then we see our 3 nodes here as well, node 1, 2, and 3. And so I can now interact like I would with Docker normally. So I'll do let me pull in the Ghost image. So for those that don't know, Ghost is a blogging platform written in Node.js. So we're going to grab the latest image of that, and then we'll spin up some of these as soon as it's done downloading. I kind of sped through the swarm stuff so far. What questions do you have while this is downloading? Yes.
So Swarm Manager, right? The manager is running on separate host.
Yes.
Right? So if the Swarm nodes, if they register with the manager,
Yes.
I saw you running Swarm, and each one of them.
Yes, that's right.
That's a lightweight
Yes,
app, right?
that's right. It's a container, actually.
That's actually process running
That's right.
continuously, right?
Yeah.
That is the one which is talking.
Yes, exactly. Yeah. So so it's going out to the internet, and then referencing that token that I passed in, and then on their end they have a they have a key value store that is referencing that token to the collection of nodes that that are part of that, and then the IP addresses, so that way they can then talk to each other.
So you could figure out the yes. I was thinking you do it you actually figure it out.
Mhm.
Why doesn't the Swarm then running on the node itself? Why can't it be
So I guess one thing that we didn't mention is that when you are executing a container, it's using software-defined networking. It doesn't know anything about the host. So it doesn't even know the IP address of the host because it's running on its own gateway that is inside of the Docker engine. Does that kind of make sense? Yeah. So so it's created its own gateway, its own subnet. They're all isolated, and so each Docker engine has its own network essentially.
It has its own DHCP server, is that what you're
Yes.
saying too? Okay.
Yes,
DNS.
that's right. Yep, and DNS as well. Yeah.
Those are private IP addresses, those a lot.
Exactly.
Used again by a lot of people, so there's a lot of swarms that have the same IP address.
Exactly.
So how will they find somebody else with the same IP address?
Yeah. So
Math.
right. So in the case where I'm running VirtualBox, it's specifying an IP range that my host understands, and so so on my computer, my swarm, my manager, and my container and my nodes, they can hit those IPs to register. But if you had one of these nodes up on your machine and you had one of these 192 whatever, we wouldn't be able to talk to each other.
right? So the manager has to talk to the host, Docker host.
Yeah.
The whole communication is going to all the nodes through the host,
Yes.
even the manager. Right?
Yes. Right.
So basically,
I'm trying to see the security and stuff.
Yeah.
unless they're all in the same little subnet.
That's
they'll
right.
Be able to talk,
That's right.
and it doesn't really work through that.
So that's right, exactly. And so what exists are some network drivers that you can use. I wasn't really going to demo that here, but that's actually how I'm doing my multi-data center stuff. So there's a network driver called Weave, and it does NAT traversal, and so that way it converges all these software-defined networks as if they were all in the same gateway on the same subnet, even though they're in different data centers. Yeah. So it's really cool. Anyway, so Ghost is done. So what I'm gonna do now is I'm gonna use Docker as usual. So I got it. All right. So each of these hashes here refer to a new Docker container instance ID. So if I do Docker PS, I will see that. Let me see if it gets too small. Let me know. But I was just trying to make it easier to read. So you can see these here. So this refers to the node name, and then here are some random friendly names that refer to these instances, because the container ID is over here, and it's kind of hard to reference. What we see over in ports, so each of my Docker machines correspond to an IP address that I can reference. So each of these are one of those VMs in VirtualBox. And then I've assigned a random port mapping that goes and makes it accessible from the host. This is the port that it is serving on internally to the container, though. So so the container specifies a port, but when I did the Docker run, which that's what this capital P is actually doing, it's saying whatever this container is exposing, just assign a random port to it. So I'll show you what happens if I go to there in my browser. Here again. Okay, so I've got Ghost running. Not only do I have one instance, but I've actually got 5 instances. So if I go to another one of these. So it's got the same IP, but it's got different ports. So that means that there's multiple containers running on the same host, which means totally 2 separate applications, but they're just occupying 2 different ports. So, but they're isolated from each other. They don't know anything about each other.
Randomizing is the port and IP combo.
Well, so the port is being randomized, but after it picks a host, it's using the IP of the host. Yeah. So if I pick another one, still, oops, I need a 1 at the beginning, and I have another Ghost. So let's say I wanted to have 5 blogs, I could have just spun them up real quick right there, and now I could go through the registration process and start making my content. It makes it really easy and really fast to scale websites or applications really, really fast. Much faster than if you were spinning up, say, 5 virtual machines that had Ghost on it. If you had like VMware or VirtualBox and spinning all that up, you'd be waiting minutes. And if you're doing a Windows application, you could be spending even more than that, like almost 30 minutes.
A full chef converge from 0 would take a really long time.
Yeah, but here you saw that it's spun up in a multi-host environment or multi-host scenario, and then just spun up, all 5 of those.
So does it do any load balancing for this?
So yes, there are, load balancing. Now, if you want true load balancing, then there's a container for that. And you can have a little bit more of a complex scenario where, let's say you're hosting an Nginx container or like an HA proxy container. Some of those containers allow it to listen to environment variables that make them aware of the other containers that are running on the host. It gets more complicated from there, but essentially the cool part is that I can destroy one of these Ghost containers or spin up even more, and then the Nginx or HA proxies can auto refresh when something changes on the host. So that way it will instantly become aware of new containers that are running. So when traffic comes in to Nginx or HA proxy, it'll then just pass it along to one of the other ones, one of the other containers that are serving Ghost, for example.
Yes.
In your multi-data center scenario, how are you managing the different environment variables for the different, like if one swarm host needed to know a little bit something different in their environment versus the others, how's that managed?
Yeah. So.
Is that a function of weave, which is not?
Well, so like, so can you be more specific about environment variable differences?
Even in my learning, I'm not. I don't remember how when I'm on development, I have those development parameters. When I take that same image and I move it to, so what is that thing that's keeping my environment variables separate as I go from environment to environment?
Yeah. So, well, like you were using a Docker Compose before. Perhaps you would check in different versions of the Docker Compose file, one for dev, one for QA, one for prod or whatever. And so you would run Docker Compose up -d, and it would refer to the environment variables that were in that Docker Compose file.
So that'd be a function of the build.
That's right. Well, it's really for deploying. Like, you don't have to have a build step in your Docker Compose, but if you do, then you get both build and deploy from a single tool. If you don't have the build steps in the Docker Compose, it's really great for just deploy orchestration. So, all right. So let's see. So let's do a brief overview of strategy. So we use the strategy of spread above. So strategies are when you have a multi-host scenario. Strategies will let the Docker host decide how to deploy the container. So let's say you had limited resources on one host because it had so many containers on it. A strategy would say, okay, well, let's give that one a break. Let's move them on somewhere else. So, so the spread strategy, in that case, it will find the node with the least containers and then deploy it there. And so this is the default strategy if you don't specify one in your swarm. And so, so one note is that a container occupies resources during its life cycle, including the exited state. So when a container, when an application inside of a container closes, whether it's finished processing or it fails, the container enters an exited state. And so it will continue to occupy ports and other things, other resources, even though it's not currently running or executing. So you'd have to actually delete the container if you wanted to free up the resources. So, but I mean, when you're doing Docker run, for the majority of the time, you're expected to run a process that never ends. That it's always running. So like a web server, it would just loop forever. Always be listening for connections. So. Yeah. So anyway, so we'll do an example real quick of this spread stuff. I'm gonna pull in some images. We'll get MySQL and Nginx, and we'll let that download. However long that's gonna take. Any questions?
Do you think are they ever going to come up with a UI to control like Ambari, for example?
Yeah. So yeah, that's right. So yeah, there's an application that's included in the Docker toolbox. I called it Kitomatic, but it might be Kitomatic. I don't know. Yeah. So that's a UI so that way you don't have to deal with the terminal here. You can just say download this image, press play, specify some environment variables, and then the container runs and whatnot. So. Yeah. In fact, even from that UI, you can jump into the container and execute some additional commands or whatever. So, that's pretty. That's right. Yeah. It's a pretty cohesive experience. Other questions? Yes.
So I see this is great for I have these nodes and I want to distribute across them. How does it handle it? Is there anything with failure as far as it detects this node's down, it's going to roll containers over? Yeah. So out of the box, it does not have any kind of roll to another system. However, Docker is meant to be seen as a primitive.
And it's becoming, you know, more robust in the Docker ecosystem, you know, since they're using like Docker Machine and all these things. But really, what this is leading to is full-on, you know, platform as a service type systems. So an example being OpenShift. So OpenShift is it's a Kubernetes distribution from Red Hat. And so it provides some superpowers on top of Docker that allow for the scenario where if I've got a host that just disappears, it'll go ahead and migrate containers to a new host and then, you know, keep it up all the time. And then other cool things about OpenShift is it's got this idea of source to image. So it could be watching a GitHub or a GitLab repository or something on your internal, you know, source control system. When it detects a change, it'll start a build process that ultimately leads to a Docker image. And then it'll then push that into Kubernetes. So that way it then spins and orchestrates and then does all the high availability stuff from there. So it really is as a platform as a service as you can get. You know, it's as Heroku-ish without really, you know, I mean, you still manage the hardware. You know, you're still responsible for all the hosts, but it gives you a very similar feel as like Heroku or dealing with another platform as a service. Yeah, yeah. And I don't know if you saw, but like Red Hat now owns Ansible. So I mean, they're all, you know, they're really investing in this kind of stuff. Yeah. Okay. So let me also get Nginx. We'll keep that going. How am I doing?
You mentioned Kubernetes.
Yeah.
What's your feelings, just general feelings on Mesos too?
Yeah.
Where that plays.
Yeah. So I actually haven't played with Mesos yet. So but I have deployed my own OpenShift. So I use that. I used that in my multi-data center scenario before I just did the Docker Swarm stuff. At the time when I tried it, OpenShift was still a little too beta for me to keep on using it. So I decided to let it bake a little bit more. So which their upgrade story is still kind of nebulous. It's like, oh, if you need to upgrade to the new OpenShift, like kill the host. Like, oops. That's right. Yeah. Yeah. Right. Well, so I mean, it's not quite like Angular 2, where they're like, don't write your stuff anymore. Write it this way.
Right.
Like, it's instead, it's like, well, destroy the host and then, you know, bring up a new one in the new version, but then like destroy another host and then bring up, you know, the new version and connect them together. And then like, you know, there's this kind of like, you know, migration and waiting and stuff till you finally get them all upgraded. I know that like newer versions now have even like a yum. You can do like a yum upgrade, and so it's a little bit easier. Yeah, like yum upgrade and then restart the service, and you know, might be happy now. So, okay, so we were looking at the spread strategy. I'm going to start a MySQL container, so the -m here says like reserve a gig of RAM. So to this container. That's something we didn't really talk about before, but like if you don't quota your containers, you run the risk of it using too much resources on the host, and then you could like kill all of your instances. I had this scenario happen recently where one of my containers used like all 12 gigs of RAM, and then I started getting calls like, hey, something's down. And I said, oh, you know, I was waiting for them to upgrade that server to 16 gigs. So, yeah. What, this feature? Oh, so I think it's been there for a little while, but I mean, but little while is relative. I mean, Docker's still moving pretty fast. So like, you know, they're at 1.10 now. So.
Yeah, I thought it was coming from 1.10.
Oh, really?
The containment feature came in
Okay. Okay. Yeah. Maybe. I mean, I'm running 1.10 here, so like it's always worked for me. I didn't really use that feature before though, as you know, my story indicates. So now I'm going to run a Nginx container. So if I Docker PS, we can see at the top there's my Nginx one there and my MySQL one there. So, and then one is running on node 3 and the other one is on node 2. So, yeah, so the way that the spread strategy worked was that it just found, found a node that had the least containers on it, or in the case that we had before, all of them had one container on it. So it's just going to pick one and then, put one on there. And so as you saw, we had so this one here was, this container was, we gave it an alias name of front end, and then this one here named DB. And so, they ended up on different nodes because of the spread strategy. Another strategy is the bin pack strategy. And so this strategy will find the node with the most resources in use, or the most containers, and deploy. So this can help you save up resources on other nodes. So for example, let's say you had a lot of really small web servers. Well, binpack would put them all on one node, so that way you can put your MySQL database that gets really big and needs a lot more RAM or more hard drive space or something on another node. So here, let's kill some stuff. Okay, so I killed all my containers. So we're going to switch over to this bin pack. The command that I am executing here actually kills my swarm manager and then spins it back up with the new bin pack strategy. Because they're still sharing the same token as before, all the nodes will rejoin as soon as this guy comes up.
Can you change the swarm strategy without killing it?
So yes, you can. If you jump into the individual manager instead of into the swarm environment, you can go and stop the swarm manager and then run an individual Docker run container and pass in different flags. And then you didn't have to kill the host. So in that case, yeah, I mean, like in my case, this will still go pretty quick. We're just doing VMs.
I had a question. You mentioned security a bit ago, and you labeled it something about internet fodder. I think I heard
That was him. Yeah. That's right.
Internet fodder, the security thing. Security on containers is still not as I thought generally as great as well as VMware security is. Right?
Yeah, but I thought of it like when I'm in production, I would still be inside of the VPC and I would still be controlling that.
Yeah, I guess I'm thinking between apps on the machine. So I mean, you don't know who's next to you on that same machine. So I thought that was still under a lot of work today continues.
But if the containers are primitive, then you would still have to secure your environment separately. That's the way I think of it. It's an easy target. It's my opinion. Like, oh, you're doing this really cool thing. I can always target you. Like, but you didn't think about mine. It's just kind of a no thing, right? I didn't see it as a drawback for whether to use it or not because there's so many other things that I can use to secure it. Like even in Amazon, I can use ACLs to make sure that this port isn't talking from that thing to the port on this thing.
Yeah, I know CoreOS has Rocket, and they've gotten a fight with Docker for a bit over security, but I don't know what the answer is.
Yeah. One interesting thing on security, though, is that so you see how we've got these ports referenced here from the container. So even though it's running an operating system like Ubuntu underneath and all these other things that may be included in that, you're limiting your surface area to only the port that the container is wanting to expose.
Absolutely, but I thought one of the problems now still was that the Ubuntu underneath that, or the core or Docker underneath that, is still not secured officially by whatever.
Yeah.
So I mean, I agree with your attack surface on your
Right.
containers is pretty small.
Yeah.
Handful of ports. So.
Right.
But
Yeah.
the actual understanding is not.
So one of the interesting things is that so a lot of the official Docker images for applications like Elasticsearch and Redis and other things they have historically been on a base of Ubuntu. Well, that's changing now, and they're migrating all of the base images to Alpine Linux, which is like just it's super bare bone, and there's definitely not a lot of room for attack on it, and it seems like it's got a little bit more power than BusyBox, so it really is like super thin, and so it should in essence be more secure in that there's even less attack surface. Another cool thing about it is that by moving to Alpine, the container sizes have significantly decreased. So I'll show you an example. If I look at my Docker images, you can see the size here. So like 354 megabytes for this Ghost container. Well, so that's because it includes Ubuntu and apt and all those different packages and all these other things in it. Well, when they move to Alpine, this will likely be like, 20 megabytes. So like it really cuts it down a whole lot. And in fact, it's really led to this ecosystem of Go applications where people they write these static binaries that are deployed on top of Alpine, and then it really is just that one small single encompassing application written in Go, and then Alpine. So it's like, yeah, it's no additional programming language runtime. Yeah, like you said, no Python, no PHP, no .NET, no Ruby, any of that stuff. So yeah.
One of the things is that there is a Docker security blog that's on Docker itself. They told about new features for security that are released with 1.10. One of them was containment, and there were other about resources and how you can do even more securing with the Linux.
Cool.
Containers.
Yeah.
So that might be a good article to read.
Yeah. Did it require you to be like on a CentOS base or something like that?
It's just a blog out there.
Yeah.
It describes how to implement some of this.
Okay, cool.
Yeah. Came somewhere in January or December this year.
Okay, cool.
Last year.
Yeah. If you find the link, you should post it in Slack so I can read it later. All right. So we changed our strategy to bin pack, and if you notice, all of them went on node 1. So I redeployed Ghost, all 5 of them. I redeployed MySQL and Nginx. All of them went on the same node. And that's because it's trying to pack it in on one host. And when that one does not have the resources, whether memory or otherwise, to handle it, it'll just go to a new host. Okay. All right. So there's another strategy random. I'm not really going to demo that one, but this one doesn't really take any regard in CPU or memory or any of the other stuff that other strategies we're using. Random just picks a node at random to deploy to. So yeah, I didn't think.
You mentioned that I understand picking the node at random, but what does it use to decide there is what resource does it?
Yeah. So
I understand the 1 gig memory constraint, but
yeah. So I just did Docker info. This queries all of the hosts to find out information about it. How many containers are running, how much reserved memory there is. There's reserved CPU stuff as well. Whether the node is healthy or unhealthy, based on whether it can talk to the swarm manager or not. Whether. Yeah.
If you don't reserve CPUs or memory or whatever,
yeah,
you can stuff a billion things on a node.
Well, until it runs out and then dies.
What?
Oh, runs out of the resources, and so then the host closes down. Like, so, I mean, you can still watch this stuff. Here, I'm gonna jump into a container real quick. So we'll do, look at the manager.
Because I don't understand what it uses to decide its. I mean, the CPU usage is 99.9%.
Yeah. So if you don't,
I may be dragging you off.
Yeah, if you don't specify quotas in reserve stuff, my understanding is that it doesn't know until it becomes unhealthy. and it only becomes unhealthy because the node is no longer responsive. So if you place quotas in, you protect yourself from that risk.
Quotas are upper limits.
Yes. Yeah.
Reserve space.
Right. Yeah, that's right.
Okay.
Exactly. But okay. I mean, I guess. So I SSH'd into one of these. I was going to look at process stuff, but it could also be, though. I mean, and this is speculation. It could be that the Docker host does have a peg on like the RSys log or something else that is getting info from the host, and so Swarm is able to take advantage of that stuff. So that's just speculation, but maybe it's in there. Okay, so we looked at strategies. Next, we can look at node filters. I'm just going to breeze through this because we are 20 minutes over. All right, so we're having fun, right? So in constraints, you can specify things like labels when the Docker daemon starts. So for example, let's say I have a host, and my host has SSD on it instead of drives that have RPMs. Okay, and what I can do is when I start the Docker daemon, I can do -- label and then put in a label like storage equals SSD, and then when I execute Docker run, I can put in this environment variable that says my constraint is that storage needs to be equal to SSD. So it's going to query for a host where that is true in this case. So in this case, I'm using equals, but you could use not equals. You could use equals tilde. So if you use equals tilde, it's going to say check this condition. But even if none of the hosts match it, go ahead and deploy it somewhere. So let's see. And then there's another filter called health. So instead of passing in -e constraint something, you would pass in -e health. Basically, that says make sure that at least the node is healthy before you deploy to it. So otherwise, it would try to send it to an unhealthy node and then fail. So you'd have to try again. Next, let's talk about container filters. We just covered node filters. Now it's container filters. So there's one called affinity. So in some of the examples you saw before, I had a container and I gave it a friendly name of front end. Another one, I gave a friendly name to DB. So in this case, it's saying when on the node, when a container exists with the name front end, or when these are actually supposed to be on 3 different lines for examples, but so we'll tackle this first one. So if the node has the container called front end on it, then this new container can be deployed to that same host. So this is important if you don't have something like Weave that can talk about networking among different data centers, and you need these containers to be close to each other. This kind of container filter is really helpful. Instead of using the friendly name of front end, you could also use the container ID, or you could even use that the container derives from the image called Redis in this case. Was it clear to you what the difference between an image and a container is? Just wanted to make sure. Yeah, cool. Okay. Next, you have dependency filters. So in some cases, you might want to mount a volume on your container, and so there are these things called shared volumes. If you want to say that this container depends on that volume being available on the host, then you would pass this in. Or let's say that you depend on a container to link to. They both need to be on the same host. You could use this link filter, or this net filter that shares network stacks. So, and then finally, there's the port filter. And so basically, if you create a container and you specify the port, like port 80, this automatically applies the port filter. So it looks for a host that is not currently using that port, and so then finds another one. Otherwise, if all of the nodes in your swarm are using port 80, it'll fail, not deploy a new one. So, questions? All right. Okay. So we're only 25 minutes over. Sorry. If you have more questions, shoot them on the Slack channel, DevOps Live, in the DevOps Engineering Slack team, and then we will see you next time. So thanks a lot, guys.